Let's talk about raw, unadulterated power, SpaceX's Raptor 3 engine. This is not just a piece of hardware, it's a symbol of human ambition and the relentless drive to push beyond our limits. This isn't just another rocket engine, it's the heart of Starship, the vehicle SpaceX believes will take us to Mars. The Raptor 3 is the beating core of a spacecraft designed to make interplanetary travel a reality, not just a dream. Raptor 3 is the result of relentless refinement, building on lessons from Raptor 1 and 2 and pushing them to the limit. Each iteration has been a leap forward, with engineers learning from every test, every failure, and every success. Every component, every weld, every pipe has been scrutinized and improved. The attention to detail is staggering. Nothing is left to chance when you're building for the stars. This engine represents a fundamental shift in how we build machines that could carry us to other worlds. It's not just about power, it's about efficiency, reliability, and the ability to be reused again and again. Why care about a new rocket engine? Because engines make everything else possible. They are the foundation of every great leap in space exploration, the force that turns science fiction into science fact. Without a powerful, efficient, and reliable engine, a rocket is just a big, expensive metal tube. It's the engine that transforms potential into motion, and dreams into reality. Raptor 3 is designed for mass production, reusability, and the kind of performance needed for missions that once seemed like science fiction. It's built to be manufactured at scale, to fly often, and to come back for more. The vision is clear. A future where rockets are as reliable and routine as airplanes, and where the barriers to space are lower than ever before. It's the workhorse for the next generation of exploration, from building lunar bases to setting foot on Mars. The Raptor 3 is the engine that could power humanity's greatest adventures. In this video, we'll pull this engine apart figuratively and see what makes it tick. We'll break down the technology, the innovation, and the vision that brought it to life. We'll explore its power, clever design, and the philosophy behind it. From the smallest bolt to the largest chamber, every detail has a story. We'll also look at the challenges, because every innovation comes with risks and trade-offs. The journey to Raptor 3 has been filled with obstacles, but overcoming them is what makes progress possible. This is the story of Raptor 3, an engine designed not just to fly, but to change how we think about flying. It's about reimagining what's possible and daring to go further. So grab your safety goggles. Things are about to get explosive. Let's dive in and discover the future of rocketry together. What makes Raptor 3 special? First, sheer power, over 269 tons of thrust. That's like 40 elephants pushing your rocket skyward. But power isn't enough, efficiency is king. Raptor 3's full-flow staged combustion design wrings every drop of energy from liquid methane and oxygen. High efficiency means Starship can carry heavier payloads or travel farther. Visually, Raptor 3 is cleaner and more streamlined. No more plumber's nightmare of pipes and flanges. Welded structures replace bolted connections, making the engine lighter, stronger, and less prone to leaks. This combination of power, efficiency, and robust design sets Raptor 3 apart. It's built for reusability and mass production, a true leap forward. Raptor 3 is a beautiful piece of engineering, purpose-built to break records and push boundaries. SpaceX lives by a simple rule: the best part is no part. This radical mindset drives every decision, from the drawing board to the launch pad. It's not just about building rockets, it's about rethinking what's truly necessary for space travel. Every component must justify its existence. If you can remove it, you do. This relentless pursuit of simplicity means constantly challenging assumptions and questioning why each part is there in the first place. Fewer parts mean fewer things that can break, less weight, and lower costs. It's a philosophy that rewards efficiency and punishes unnecessary complexity, making every gram and every connection count. In a rocket engine's extreme environment, simplicity equals reliability. The fewer the moving parts, the less there is to go wrong when the stakes are highest. Raptor 3's welded design is the ultimate expression of this philosophy. It's a bold step that pushes the boundaries of what's possible in rocket engineering. By replacing bolted flanges with welds, engineers eliminate leak paths and failure points. Welds create a seamless structure, making the engine more robust under pressure. This approach also shaves off weight, critical for rockets. Every kilogram saved can be used for more fuel, more payload, or greater range. Lighter engines mean more payload and better performance. It's a direct line from design philosophy to mission success. Of course, welding everything together makes repairs harder, but the trade-off is increased reliability. SpaceX accepts this challenge, betting on fewer breakdowns over easier fixes. SpaceX bets that robust design and fewer parts mean fewer failures. The data from countless tests backs up this bold approach. This philosophy forces innovation and constant questioning. It's a culture where improvement never stops, and every idea is tested against the standard of simplicity. It's why Raptor 3 looks and performs so differently from any engine before it. The result is a machine that's leaner, tougher, and more advanced. Minimalism isn't just a style, it's a survival strategy in space. For SpaceX, less truly is more, and that's what sets them apart in the race to the stars. The leap from Raptor 2 to 3 is all about smarter, simpler engineering. Raptor 3 integrates plumbing and cooling directly into the engine body, using advanced welding for a cleaner, more robust structure. Fewer bolted flanges mean fewer leaks and higher reliability, crucial when 33 engines fire together. The cooling system is upgraded too. Cryogenic methane circulates through channels in the engine walls, cooling them and preheating the fuel for better efficiency. These upgrades let Raptor 3 handle higher temperatures and pressures, unlocking more thrust. Simplified plumbing and better cooling make the engine lighter, safer, and more powerful. Each improvement feeds the next, creating a positive feedback loop of performance and reliability. That's how a good engine becomes a great one. No machine is perfect. Every engineering decision is a trade-off. Every improvement in one area often comes at the expense of another, and engineers must constantly weigh the pros and cons of each choice. Raptor 3's startup sequence is a complex ballet. A tiny error can cause a hard start and serious damage. The choreography of valves, pumps, and igniters must be perfectly timed, or the consequences can be catastrophic. Welding everything together makes the engine stronger, but repairs are tough. If something deep inside fails, the whole engine might be scrapped. This approach increases structural integrity, but it also means that even a minor flaw can lead to major setbacks. SpaceX is betting that increased reliability means failures will be rare. Their philosophy is to build engines robust enough that, ideally, they won't need frequent repairs. Raptor 3 operates at the edge of material limits, immense pressures, and scorching temperatures. The engine's components are pushed to their absolute extremes, where even the smallest weakness can become a critical failure point. Real-world testing is the only way to know if it holds up. Simulations can only go so far. Only by firing the engine can engineers truly understand how it performs under stress. Pushing the envelope means some tests end in spectacular failure, but each one teaches valuable lessons. Every explosion or malfunction is a data point that helps refine the next design. The robust, welded design is a calculated risk. Harder to fix, but less likely to need fixing. It's a bold move that prioritizes strength and reliability over ease of maintenance. The line between success and failure is razor thin. At these extremes, even a tiny oversight can mean the difference between a flawless test and a catastrophic failure. These are the risks SpaceX accepts to build a revolutionary engine. Every discarded part and failed test is a step toward a more reliable future. Starship's success depends on managing these challenges through relentless testing and improvement. It's a journey of constant learning where every setback brings SpaceX closer to achieving their ambitious goals. Starship's revolution isn't just in flight, it's in how it's built. SpaceX aims to mass-produce engines, not handcraft a few. Raptor 3's simplified welded design is made for rapid, high-volume production. Each Starship launch needs dozens of engines. Mars missions will need thousands. Fast production is a strategic advantage. Engines can be built, tested, and improved in weeks, not years. Failures aren't disasters, they're data points for the next iteration. This rapid cycle accelerates evolution and improvement. Mass production is as important as performance. It makes reusable rockets economically viable. Cheap, quick-to-build engines make Starship's vision possible. The dream of Mars depends on building thousands of reliable engines fast. Raptor 3 isn't just designed to fly, it's designed to be built at scale. In engineering, theory is nothing without real-world testing. The test stand is where Raptor 3 proves itself. Every test fire yields data, pressures, temperatures, vibrations, revealing strengths and weaknesses. Real-world testing exposes problems simulations can't predict. SpaceX's philosophy test: fly, fail, fix, repeat. Raptor 3 has shown promise, but the real test is reliability over hundreds of flights. Each flight's data makes the next one safer. If Raptor 3 proves itself, it could become the most important rocket engine of the century. It's not perfect yet, but it's a bold bet on a new way of thinking. Raptor 3 might just be the engine that carries our dreams to the stars.